What I'm going to quickly talk about what is the ISS, what's its purpose. We'll then be going down some facts, figures, records, and then we'll be delving more into the amateur radio equipment. I've got a couple of examples as well, which are videos I've gotten from YouTube, which show you how the communications sound like. Obviously, it's like you have a normal conversation over the radio. However, the way you speak to them might be slightly different because they're not going to hear you as well. And you really have to try when they come into the window where there's a possibility of you speaking to them, you really need to try and butt in quickly, because as soon as the window opens, there will be tens, if not hundreds of people trying to speak to the astronauts who are in space at the moment. So it can be quite competitive. But talking about what the ISS is, it stands short for the International Space Station. It's one of the largest multi-nation construction projects which has ever been put into space. Construction mainly was between 1998 and 2011. However, there is still new modules being sent up. They have just recently completed a spacewalk, which was on the 5th of February. No, I'll talk about it in a moment. I think it's the 27th of February. Just recently, it's been all over the news. It was the 235th spacewalk. And the idea of it was to basically install some new modules for the solar panel arrays. They're basically are being renewed slightly, and they've had to put some attachments up. Next spacewalk, for example, number 236 will be on the 5th of March. So it's not kind of been told yet how long it's going to last. The last one, which they've just done to build these modules or put them on, lasted about 7 hours. So for 7 hours, it took him to basically suit up, go out into space, do the repairs or put the modules up, and then obviously go back into the spaceship itself and dekit. It's been continuously occupied since the 2nd of November 2000. So in the first couple of years, they've just sent some astronauts up to do a little bit of work and then basically come back down again. But as of July 2020, so the figures obviously are constantly updating because we're sending more astronauts up there. There have been 242 individuals from 19 countries. And obviously the biggest ones we could think of would be the United States or NASA. Russia, obviously, they're partaking as well. They are called the Roscosmos. So that's their kind of big brand name. Canada, Japan has been involved. Europe, which is the ESA, the European Space Agency. And obviously, they've got a lot more in this kind of brand name. They've got Belgium, Denmark, France, Germany, as well as the United Kingdom. So we've sent a couple, like Tim Peake, for example. He's been one of the biggest birds who's been sent up. Now, the current plans only go until 2024. However, there have been possible extensions planned up until 2028. And until then, we're not really sure what's going to happen. The biggest thing up there is radiation. So that can degrade metal, for example, or some of the components which are there. But you really haven't got the issue with oxidation because you're not really going to be around water. There's not going to be much wind either to break some bits to pieces, basically. But the biggest thing is radiation, as well as some when you've got like little comets or meteors, they can also strike some surfaces, for example, and cause some damage. I've just popped in a little diagram of the ISS. I hope that's good to see. I'm not going to be able to go right into detail as to what this means. You can see there is 4 big arrays, all comprised of 8 smaller solar panel arrays, and then you've got various different stations, some which have been brought up by the Russians, some have been brought up by the Americans. The most important one for us is the one on the kind of top left-hand side of the screen, which is the service module. That's where some of our amateur radio equipment is actually kept. And then the other one would be on the right-hand side, lower middle. There is the Columbus orbital facility as well. And that's where the Russians have got some equipment as well, which is used for the amateur radio, of course. So talking about what the purpose actually is. So it's made it possible for humans to have an ongoing presence in space. Basically means we've got some kind of pressurized capsule floating around up there where we can send people up and stay there a little bit. The other thing is we've got these labs up there where the crew members can conduct scientific research, and there's been a lot of stuff gone off. I've got 5 examples here. For example, we've been able to explore the 5th state of matter. So what they've been able to look at, that was probably about 25 years ago now, they've produced the 5th state of matter. So initially we were aware of solids, liquids, gases, and plasmas. Now, the 5th one they've discovered is the Bose-Einstein condensate, also known as the BEC. They've been looking at identifying unknown microbes in space. Initially, you'd have to gather some kind of sample and then send that down to Earth to be analyzed. Well, they have now been able to formulate a method in order to do this in space. So if they find some unknown microbe, they can identify what it is, kind of repopulate it as well, so they're more aware of what's going off there. They've been doing some drug development. Now, not the drugs which are legal. They've been looking more along the medicine kind of pharmaceuticals using protein crystals. So they have been able to create protein crystals in 0 gravity. Because it's not affected by gravity, they actually grow a lot quicker, and the bonds are a lot stronger as well because they're not being broken down by gravity. So these have been used, or these protein crystals have been used to treat various diseases, from cancers as well as to gum diseases. So if you go to the doctor or dentist for gum disease treatment, more than likely you will have had some kind of component in you or been treated with, which may have started out in space and has kind of been developed there. Now, another thing they've done, they've collected more than 100 billion cosmic particles, which have basically collected a lot of information, which shows us what's flowing around in mid-space. But the biggest one we really use the ISS for mainly is monitoring our planet from a unique perspective. So we have got this observation platform there in space where we can look at the Earth's water, air, land masses, vegetation, and more. I mean, we always say you can see the China wall from space. Yes, you can. The ice caps melting and things like that, we have been able to track through the ISS as well. So it gives us a unique advantage point there to kind of show us what's really going off. Talking about some facts and figures then. In 24 hours, the ISS will travel around the globe, doing 16 orbits, which strictly speaking means you are going to be experiencing 16 sunrises and 16 sunsets. They are traveling ridiculously quick. I'll give you the number in just a moment, but Peggy Whitson from the US has set the record for spending the most total time living there and working in space as well, which currently still stands at 665 days, which she achieved on the 2nd of September 2017. Talking about the kind of capacity there, the living in the working spaces on the station is actually larger than a 6-bedroom house. It's got 6 sleeping quarters. Again, they're not going to be your master kind of bedroom or double bedroom. They're a lot smaller. You're going to get bunk beds, and that's about it. 2 bathrooms. Again, they're not going to be an ensuite with a 3-piece suite. They are going to be pretty much like a sleeping bag, which you fill with water and you shower in there. You've got a gym, though, and the 360-degree view bay window, which, again, is being used for observation as well. One of the biggest one we're actually looking at is the effect of zero gravity on the human body. And to mitigate the loss of muscle and bone mass in the human body, they have to do a workout at least 2 hours a day. That's where the gym comes in handy. Again, because you're in space, you're floating around, you're exposed to zero gravity. Your bones don't have to keep your body upright. If you compare someone who's floating around in space to someone who's standing on planet Earth, the gravity will want to pull them down onto the ground. So we're using our muscles and bones to actually stand up. In space, at zero gravity, they start to degrade. So we need to kind of counteract that. And that's been one of the biggest scientific researches they've been doing, looking at what effects the zero gravity has on the human body. I've got a few more figures for you. Talking about the spacewalks, so at the moment we have conducted, or these have conducted, 235 of them, but they're still counting, and that's mainly for space station construction, maintenance, and upgrades, and these have happened since December 1998. So currently we have got mission 64 up there floating around. And it was actually the 28th of February where Kate Rubins and Victor Glover were doing the spacewalk for 7 hours and 4 minutes. And that was to basically install some modification kits, which is going to be for this upcoming solar array, which is going to be brought up at some point. The solar array wingspan itself is about 240 feet. So I'm going to talk about wingspan, which means from end to the other side. And it's about the same length as our world's largest passenger aircraft, which is the Airbus A380. You don't really see many of them around, but it's a huge thing. It's got 4 engines. It's absolutely massive. It needs proper or correctly sized runways as well to actually land. So it's not going to be able to land everywhere. It has to be the right airport for that kind of size of plane. In total, you can have about 8 spaceships, which can be connected at any time at the space station. So there's various different kind of docking ports where you can land. And in total, they're using about 3 million lines of software code on the ground support. So that's the station on ground on planet Earth, which is monitoring what's happening up in space. And they're using about 1.5 million lines of flight software code. So it's just absolutely baffling numbers. We can go a little bit more in numbers, which basically tells you about the different areas. So strictly speaking, we're looking at this pressurized module length. So pressurized means these are areas where a cosmonaut or an astronaut can be, without any extra equipment, breathing normal air. Not all modules are pressurized at all times. It's only the ones which are utilized. So that length only equates to about 73 meters. If a module is not required, so let's say it's been docked on, it's been put into the ISS, it's been connected, etc., they've done the work inside, they will depressurize it because it doesn't need to be kind of occupied at a later point. If they need to do some maintenance, they will have to pressurize it again in order to get into it. The whole truss length, so again, looking back on the diagram, that's from one end to the other end, it's about 109 meters. And then the solar array length itself, so I'll just jump back to the picture for you. It's looking at the bottom left. So you've got the 2 blue lines up to the left and then 2 blue lines going down to the bottom. Each one of them is a solar array. So the one up to the left is the 35 meters, and then the one down to the bottom is another 35 meters. So you're looking at about 70 meters, roughly 240 feet in length. That whole thing up there weighs 419,725 kilograms. But more than likely, if you would have a fixed point in space, you could just touch it with your ring finger or your little finger, give it a gentle nudge, and you will probably move it. But again, when we're in space, we haven't got a fixed kind of fixing point, so we're not going to be able to do that. It then goes a little bit more into different areas, none of them which I'm really kind of going to delve into. The power generation of these solar arrays is quite interesting. It's about 75 to 90 kilowatts per hour in order to kind of power the whole ISS. But the key thing why I want to do this talk is the amateur radio part of it. And this is where our hobby comes in handy with these astronauts and cosmonauts who are sometimes as well licensed radio amateurs. So when they're able to be up in the ISS for, let's say, a lab or experiment or something like that, in their free time, they can use the license to then transmit back to Earth. What's happened, the first amateur radio equipment was actually delivered back in September 2000, and the first communication was done by Commander William Shepard. His call sign was Kilo Delta 5 Golf Sierra, and that was back in November 2000. As I said, most of the astronauts on the ISS are actually licensed radio amateurs. So as I said, during the spare time, or you can have school visits as well. Not school visits as such, but a school can book a communication. Currently, that's done through the Russian module, where a school can apply to NASA to have a certain time slot where they're then able to have a chat with the amateur radios on the ISS, which is quite interesting and quite exciting for the children. Call signs, we've got a few on the ISS. So we've got RS0 ISS, which is the Russian handset at the moment. We've got NA1 SS, which is the USA. And then we've got some European ones, which is DP0 ISS, OR4 ISS, IO0 ISS, And then we've got the packet station mailbox, which again are Russian, so it's RS0 ISS-11 and RS0 ISS-1. You can see there's a common theme. It always kind of ends in ISS. If not, they're going to use the 1 and the SS to kind of make the ISS logo there to appear. Here we actually have got a lady who is there with one of these radios. So they all have to be specifically built into little boxes. They're not going to be your over-the-counter radios. They pretty much will be, but they're going to take everything out. All the buttons are being taken out. The PCB, the actual electrical components are being taken out, rebuilt into this new box, which is a bit sturdier, fireproof in case there's a short circuit. It won't blow up the whole spaceship. It will just kind of distinguish itself because there will be no oxygen going into these boxes to kind of allow it to oxidize or to actually start causing any kind of flames. Initially, the first 2 radios sent up were from Kenwood. That was a D710E and a D710GA. The D710GA was actually located in the Columbus module, and that supports 2-meter operation, 144 to 146 megahertz, and the 70 centimeters, 435 to 438 megahertz operation. Whilst it's in ISS operation, it's restricted to 25 watts, and it's mainly supporting the FM and packet operation. Packet operation is basically the FS key, the frequency shift keying, where you're able to send some data up, similar like ARPS, the automated package reporting system, where you can send information through this data mode up into the sky, and then it gets rebroadcasted down onto planet Earth as well. The D710E was located in the service module, so that was the Russian part on the top left on the graphic. And again, it supports the 2-meter, which is 144 to 146 megahertz, and the 70 centimeter band as well. And again, this one supports FM and SSTV, that's slow scan television. So you are actually, once these are operating, you are able to receive pictures from space as well. It takes a little bit of time of decoding. You have to gather the information and listen to it correctly and record it as well before you're then able to decode it. So you can actually gather pictures or collect little pictures, which are changed on a weekly basis or whenever there's a new expedition. Like at the moment with Expedition 64, they normally have a big logo or emblem. And once these kind of change from expedition to expedition, that will change as well. Or if they're doing a spacewalk, they might just take similar like a selfie, and that's then being broadcasted down onto planet Earth for you to kind of keep and save. It's quite a good keepsake, and obviously this is something you'll never receive again once it's been broadcasted. They will ultimately change it. So if you've not had a chance to get it, you've kind of lost out. Here's another gentleman with one of the handhelds, kind of making a transmission. As I said, there's this one radio which is currently operating as a packet digipeater, and that's in the Columbus module. It's that Kenwood D710GA. It's currently dialed down to 10 watts and uses the call sign NA1SS. It will also respond to the alias ARISS. So either or you can use to kind of speak to them. The slow scan television, the SSTV, can be transmitted from the ISS. It's an integral part of this ARISS ham radio station. And again, we're using the call sign NA1SS, or if the Russians are transmitting, it's the RS0 ISS. Again, talking back on the ADSB talk I've had a few about a month ago, it's quite important that we have various antennas employed, because if we would stick him on the top and it's currently facing away from Earth, you may not be able to receive any signal down onto planet Earth. So we've actually got 4 antenna systems which are employed on the ISS, and that's currently just to support these Kenwood radios. So normally we will have these 4 antenna systems, and that means multiple. So it could be each system comprises of 2 or 3 antennas facing in all weird kind of ways in order to give full coverage. Now, talking about actually receiving the International Space Station, this is where it becomes really tricky. So frequencies we are aware of. in order to listen to something, we need to tune into a frequency in order to listen to it. However, we have got something working against us, which is called the Doppler Shift. And I'll tell you a little bit more about it. But in order to receive the ISS, it's really easy. All you need is a 144 megahertz FM rig, and you can really listen to them. I've managed it with my Baofeng £25 radio off eBay, really cheap. What I'd suggest is that we actually use a little bit of a longer, kind of like a quarter wave whip. You just have to dial into the right frequency, stand outside in the open, and actually time it right for when the ISS is doing a flyover, and more than likely you'll be able to hear them. Terms of antennas in terms of receiving, the simpler the better. As I said, a quarter wave ground plane has the high angle radiation, which means it's got a nice kind of cone where we could receive, whereas a collinear antenna is actually more difficult. I've got a collinear on my roof, and I have managed to receive the ISS. You just need to make sure that as soon as they touch the kind of horizon, when they start to appear at the horizon, which is normally about 10 degrees from ground, that's when you receive them best. As soon as they start flying overhead and are pretty much 90 degrees above you, they start to die down. You won't hear them as much, but as soon as they then start descending towards the horizon again, the signal will become stronger. As I said, you can receive them mainly outside, just using a normal FM handheld. And then in the UK, we actually use the narrow 2.5 kilohertz deviation. The problem is the ISS transmit with 5 kilohertz deviation. So we need to make sure that in our rig, we can use wide and narrow band. Luckily on my Baofeng, there is a possibility of changing from wide to narrow. And as I said, at the moment, unfortunately, because of the whole pandemic, schools being closed, there is no real need to have schools talking to the astronauts. So at the moment, the space station equipment is actually operating in automatic mode, which is this digipeater, which makes it slightly annoying because you're not able to have conversations with them. However, the repeater I was talking about, where you can transmit up to the ISS and it broadcasts back down to Earth, that's still working in automatic mode as well. And that's quite cool because you know you have been talking to someone in a complete different area. For example, Italy, you could speak to someone, but you've done that through space, strictly speaking, not with the ionosphere or on high frequency. So you've not used a low frequency and then relied on the propagation to carry a signal. You've actually bounced straight out into space to the space station, and it's transmitted it back down. In terms of how this whole CQing works, speaking to the astronauts, so that will, when they normally put a CQ call out, they'll use the frequency 145,800. And then they operate a split listening for replies at 600 kilohertz lower. So what we are trying to do is we will listen here on Earth at 145,800. And when we transmit, we want to do that at 145,200. It's just we're using it at these different kind of frequencies so that it's going to be able, similar like a repeater, it can listen and transmit at the same time. Whilst they're transmitting, they can listen what's coming back. I've got a spreadsheet in a moment which shows you the correct frequencies. But what we can do is on our rig use a repeater shift. So some of the more advanced radios, you are able to have this kind of split listening that when you transmit or key up, it actually automatically changes from 145,800, takes the 600 kilohertz off and pops your frequency when you're transmitting on 145,200. As soon as you let the keyer go, it then jumps back up to 145,800. So you can make sure you're always in the correct frequency. Please never, never, ever transmit on 145,800, just because you would be blocking out the signal, first of all, towards you. And if you have people around you listening on 145,800, let's say we've got a few people around Nottingham or even Derby, if you're transmitting with 10 watts or 20 watts, for example, you're going to bleed straight into their receiving channel, and you're not actually going through the ISS, and that can be quite annoying. The ISS has got some low orbits, but it's only about 5 or 6 times each day. And the problem is these orbits only last for about 10 minutes. So once the ISS appears on the horizon, time is of the essence. You really need to get in quickly, get as many communications as possible before the ISS then kind of goes out of the area, and you won't be able to catch them again. But again, you only wait a few hours and they appear again. Traveling the ISS does at around 28,000 kilometers an hour, which is rather quick. The problem is, with this high speed, the radio signals appear to actually shift in frequency. This is what we call the Doppler shift. It will cause this ISS transmit frequency of 145,800 to actually look as if it is 3.5 kilohertz higher in frequency. So as the ISS is appearing on the horizon, it is traveling towards you. The frequency you want to be listening to is actually ever so slightly higher than this 145,800. So we need to dial it up to about 145,8035 as it's coming towards you. And then as it's disappearing, we actually need to dial down. And you could go as low as 7 kilohertz, down to 145,7965. So it's really important that as the ISS is approaching, you're dialing up, or you're starting quite high, dialing down. And then as soon as the ISS is disappearing from you, you're dialing down a little bit even further. I've got the table for you in just a second, which shows you a little bit more about it. I'm going to see and hope if this works in terms of playing you this video, which is our amazing Sheldon Cooper, Dr. Sheldon Cooper from the TV program, which is quite famous, Big Bang Theory.
It's the apparent change in the frequency of a wave caused by relative motion between the source of the wave and the observer.
Which, yes, he explains very quickly, but basically what he's saying is the apparent change in the frequency of a wave caused by relative motion between the source of the wave and the observer. Looking at the picture next to it, that makes a lot more sense. So we've got the front observer and the back observer. The front observer is basically the position I'm going to be in as soon as the ISS is reaching the horizon, it's coming up and it's traveling towards me. As you can see, the source, which we class as the ISS, is squeezing these radio frequency signals towards and kind of pushes them together, which means the frequency will be slightly higher. That's why we have to start dialing up. If the ISS then travels away from me, which would mean I would be in the back observer position, as soon as it kind of starts traveling away from me, the frequency, or it will take longer to travel, it will start to get slurred slightly, which means we then have to dial down the frequency pattern in order to still be able to listen or even receive the ISS correctly. The biggest example is an ambulance, a fire truck, or a police car. When they're traveling towards you with the two tones, the frequency, it seems to be getting slightly higher. And then as soon as they're traveling past you, the frequency of the sound starts to become lower. So this is this Doppler effect we talk about. Visualizing this in the frequencies. So if we look at the top panel, that's the ability of talking through the International Space Station like a satellite repeater. So whenever we're transmitting, we want to transmit on this 1444900, let's say. As the ISS comes up from the horizon, we want to be listening at 437,815, and then we want to start dialing down in little increments. So we want to go down by 500 kilohertz, 437.81, 437.805, 437,800, etc., etc. I have programmed them like this into my radio as well. So I've got the ISS +3, +2, +1, and then the M, which is like mean, it goes down to -1, -2, -3. As the ISS approaches and it comes up from the horizon, I normally listen into 3. I'll give it a couple of minutes before I would consider going down into 2. Sometimes the signal isn't there straight away, or sometimes there isn't as much activity. But what you basically do is you can just start, you can track them alongside them as well on like a little app, or I've got a website I'm going to show you in a moment, which shows you the tracking. You can actually see where they are, and they draw a little radius around you as well, which is kind of the footprint of the ISS where you should be able to receive them. So as they pop up or this footprint starts touching your location, I'd be listening to ISS +3. And then as soon as they start sitting pretty much smack over me, I'd be at the ISS M, the mean. And then if they start traveling away from me, I'd be then start dialing down to -1, -2, -3. So this is the way of using it like a repeater. If we want to talk to the International Space Station, this is where slightly different frequencies come in. So again, we're transmitting on 144,490. And the receive frequency, the mean, is this 145,800. However, again, we're going to start with the +3, +2, +1, and then it goes -1, -2, -3. So initially, we'd be starting at 145,815, and we'd be going all the way down to 145,785. Again, I have saved them like this into my radio, so I've just differentiated them like on the table. If I want to use it like a repeater, it's just ISS. If I want to talk to the astronauts, I've just put an A at the end, so it's ISS-A. Both are operating in FM. Both are using a split for the offset direction, which makes it really easy because you don't really have to think about it, dialing up and down. You just key up, it switches your frequency to the right level. As soon as you let go, it goes back to the receiving frequency where you want to listen. The only difference is when you're using it like a repeater, you're going to use a little tone, the CT CSS, if I can remember correctly, which is just 67 hertz, sends a little beep just to activate the repeater. However, if we're speaking to the astronauts, there's no point of doing that. We don't need to do that because they're going to be listening. Now, I've got a couple of examples. I hope they come through. Even if the video is broken and it stutters slightly, I hope this tone and sound comes through correctly. There are a couple of examples of how these radio transmissions can sound like. The first one is a gentleman who's, for the first time, contacted the ISS successfully, and the astronaut actually has replied, and they have a quick conversation. The second one, this guy has got a much bigger setup, and he has got a tracking program as well, which he's got running in the background, which gives him the ability of actually seeing live where the ISS is. So we'll start with the first one. And this is just a really easy, straightforward communication. And that's it. It's just a really straightforward communication. As you could see at the top, he's listening to 145,800. And as he was transmitting, he was actually transmitting on this 144,900. So sorry, the 145,900. I'm getting confused now. You can see it again in the video as he's listening to 145,800, and when he's transmitting, it's at 144,490. Apologies. So he has programmed this frequency shift actually in there, which makes it quite easy for him. So as he keys up, it goes to the right frequency to transmit. You let the keyer go, it jumps back to where it needs to be. Now, this is the gentleman who's got a much bigger setup. He's got, I think, a bigger radio as well, probably more power in order to get up there. And then in the back, you can see this map. Again, it shows you day, night, and then these two little lines are your line where the ISS is actually moving. I'll show you that page in just a moment. But this is his communication with the ISS.
This is called the second pass, and we'll have about a 10-minute window to contact with the Delta Zero Alpha, Kilo X-ray. Delta Zero Alpha, Kilo X-ray, hello, this is Larry in Minnesota. Nice to talk with you. Oh, Minnesota. Man, we're a low pass for you guys, huh? Yes, you are. I'm running a vertical antenna, which is not the best way to do this, but it's working for me. That is super clear up here. Nice equipment. Thank you very much, and thank you for the contact. I'll let you make some more from Whiskey Delta Zero Alpha Kilo X-ray.
And that's that conversation over. As you've heard, he's actually using a vertical antenna. to speak to the ISS, and the lady, the astronaut, has suggested this is quite a low pass, meaning that they're going to be closer to Earth compared to when they would come round at a later point. Again, the niceties, as in saying 73 and that kind of stuff, are really out the window, because you are just making such short, really quick communications. It's just something you want to tick off. You spoke to the astronaut and that's it. They're going to move on to speak to someone else. So all the biggest things, talking about what equipment you use or what the weather's like, you're not really going to use. You're going to say, hi, I'm from such and such. This is the equipment I use. If you mention even that, have a nice day. See you later. And that's it. It's just a short, quick conversation just to say, look, I've spoken to an astronaut in space. And then that gives them the ability of speaking to someone else. As I said, this window is only about 10 minutes over your area. But as the ISS progresses along, they could potentially be hitting Italy. And as soon as they're reaching the end of Italy, they might start already hitting Kazakhstan or India, for example. So you want to give these other people in these other countries a possibility of speaking to them as well. And talking about the radio status at the moment on the ISS, again, as I mentioned, it's a little bit bare. So since we've had these first radios sent up, the D700s and the D710s, they've actually have some more which have appeared. At the moment, in the Columbus module, we're using 4 radios. The Ericsson VHF is currently used for this packet system Digipeater, which is still active. We've got an Ericsson UHF, which has been stowed away. The Marcon ISS station, again, that's temporary stowed. And the IORS, again, has been stowed. In the service module, again, it's pretty blank. The D700 Station 1, D700 Station 2 are both stowed away. And the D710E, there are supporting Russian scheduled contacts. So again, you can speak to the Russians, you can apply for it, and they kind of give you a time slot using UTC when you're able to speak to them. The reason it's been stowed primarily at the moment is there have been a lot of planned spacewalks for 2021, and you just want to get rid of any kind of distraction. So the idea is to kind of just pack everything away so that you've got good working environments and just focus on the task. Playtime always comes a little bit later. So the idea is just pack everything away. The Ericsson VHF is currently running by itself. That's doing this packet system. It's also using the repeater, but at the moment everything's kind of just packed away just for people to focus on the tasks. So the 2 ones which are active at the moment, which we can use, is the Aprs mode, which is this the RS0 ISS and the AR ISS. Again, it shows you the uplink and the downlink. So they're actually using the same frequency. The uplink is at 145.825. Downlink is the same one. And it's using this AFSK, the frequency shift keying, at about 1,200 bits per second. The repeater mode at the moment, again, it's active as well. So you are going to be listening to 437.800 approximately. Again, this is the mean. You want to have your +1, +2, +3, and -1, -2, -3. And the uplink is at 145.990. Just make sure when you are keying up, you are transmitting this tone at 67 Hertz as well. And both of them are active at the moment. This one doesn't talk about a call sign. Reason being is obviously it's a repeater. So you're going to be transmitting your own call sign for people then to receive. So this is this presentation over. However, I'm just really quickly going to jump into this page I have found, which will show you the space station and how it's flying above us at the moment. I've tried to kind of see if there's a possibility of actually doing like a live listen, but the next time it's going to come across is in 5 hours and 35 minutes, and I'm not going to keep you up for that long. So I'll just jump into the other screen, and then you will be able to see it. There we go. Apologies about the adverts. However, this page is called n2yankieoscar.com. You can stream or you can track various different stations. the biggest one at the moment will always say it's the ISS. It will cross the sky in 5 hours and 35 minutes. This mapping is similar to the one we've seen with the gentleman who's made the second transmission. So you can see your day area and your night area. It's got your ISS path, and then the sun is kind of highlighted on there as well. If we zoom in, normally as soon as it reaches over a continent, it will then start projecting a little kind of like a circular footprint, which shows you when it's actually transmitting and when you could reach it. However, once you are on this website, n2yo.com, you can actually click on the ISS, and then it brings you to, oh dear, it's now going to ask me for loads of things. Once you're on it, it actually shows you all the different passes, so you can start thinking ahead a little bit as well. It will just take a moment to load. Here we go. So at the moment, they're all a bit rubbish. They're very, very early. I mean, you've got one on the 4th of March, and you could be looking at about 20 past 6 in the morning. Again, it will show you where they will start. So let's say if you are happy to be up at quarter past 6 on the 4th of March, you're looking at west 280 degrees. It's going to then start traveling up, and it's going to go down east, southeast at 118 degrees. Again, you can then click onto the individual maps, and it will show you the paths, and it gives you like a 10-day prediction. The best ones for us is kind of summer area going into the autumn, around August, September. That's when the timings are more towards the evening, about 8, 9 o'clock at night. That's when I've done a couple of kind of listen-ins, and that was quite handy. And then you can click on the live tracking as well, which just brings you back to the page I've just showed you. So it will show you the live kind of track where the ISS is. And we'll just, it's just going to be, yeah. So here we go again. That's the same page we've just had. It's just kind of off South America. And the other one, which is quite handy, is once you're back on this kind of ISS 10-day prediction window, you have got a more info as well. Once you click on the more info, it will then show you the actual radio stations. So it gives you a little bit more data about the ISS. It shows you the different predictions you can do, etc., etc. However, this is the ones we'd be looking at. So this is the one I've pulled off, where it says that the digirepeater is currently active, and then we have got the FM voice repeater, which is currently active as well. All the others, like the SSTV, unknown, we're not sure at the moment. NA1SS is currently inactive. All the different ones, they're all kind of switched off at the moment and are not being utilized. Yeah, but this is a really handy kind of page as well. It shows you where they are predicted to be kind of coming along. Even if they're going through this kind of area of Europe, there's no chance you're going to be able to speak to them. They are unfortunately way too far away. You want the line really to be above the United Kingdom, if not France, to get a chance of being able to speak to them. But yeah, it's straightforward. You just get yourself a simple FM rig, just a bow thing, cheap thing is more than enough. You don't even need that much power. If you've got 5-10 watts, that could potentially, if the ISS is nicely above you, you could speak to them with just using that little amounts of power. People have endeavored into building specific antennas of tracking satellites and speaking through satellites and receiving images from satellites. There is a possibility of doing that as well. It's quite complicated. This page as well, you can look at satellites. You can look at recent, for example, loads of Starlink satellites have been just recently launched. And you can listen to the data coming from the satellite back as well. So I have seen people who've been able to receive weather data. So when we look at weather images, people have actually decoded them themselves using their computer. So whilst it's passing overhead, you're recording the noises coming from the satellite, the data being sent. And then you use a computer program to just decode that. It looks similar like slow scan television, where it will just build the picture line by line by line. The data is incredibly sharp you can actually get from it. Again, that's just something, if you're really into satellites. I mean, we've got a couple of people in our club who've just done their license because they are sending little CubeSats up into space. So they are going to be using that kind of system of listening to what the satellite is sending back down to Earth, and then decode it and kind of, find out what's actually happening up there in space. But yeah, that's all from me for this time. So this is just a basic introduction into the International Space Station, what it is. But I would say, if you have the chance of just having a little play, stand outside, especially if it's not too cold, and just have a listen in, because hearing something from the space station, even if it's just the repeater signal coming back down, is something quite surreal, because you just know it's been up 408 kilometer away and then 408 kilometers back down to Earth. So that's quite an astonishing journey these radio frequencies can do. But that's all from me. Unless there's any questions, I'll try to answer. But if not, I'll pass it back to Simon.